So we're talking about agentic delivery, picking up from the last webinar. This time we're going to be focusing a bit more on the operating model and mostly on the developer workflow. And we've mentioned our R&D tools before, and today we're excited because we're actually going to be demoing one. So in a nutshell, what this webinar is about, it's about the fact that agents are constantly making decisions, and sometimes they make the wrong ones, oftentimes they do. And one of the more annoying ones I've had is when I had an application, it was failing to communicate with a key vault, so it wasn't managing to retrieve the secret. I asked an agent for help, and what it did is that it added a config on the app. It changed all of the code to read from the config, and it fixed the problem that way. So the problem was solved, but obviously in the wrong way. And these issues happen all the time with AI. Some are very obvious, like in this case, where Claude deleted a production database, so we obviously catch it, but other decisions are more silent and actually make it to production. So we need to understand why this happens, and we also have to have the right process in place to avoid these situations. So this is what we're going to be covering. So we're going to look at scrutiny. We're going to look at how to manage intent. We're going to talk a lot about intent in this webinar. We're going to have a demo of Nissi, our tool. So Nissi is an assistant that sits between the developer and the agent, and it helps with the new way of working. And we're going to look at some pitfalls in team collaboration and obviously how to avoid them and how Nissi helps with collaboration as well. Okay, so what we're talking about here is not AI assisted, we're talking about agentic SDLC. And the simplest difference between the two is that the role of the human is very different. And the first stage that usually changes is the coding part. So it's one of the stages that you will see the quickest gains in, and it's the most obvious one because you just download Claude code and the developer stops writing code. But as soon as that happens, it has a ripple effect on the rest of the stages and on the team as well. So you'll see bottlenecks, you'll have new risks that you need to handle, and you'll have challenges with collaboration within a team. And that means the team needs to figure out how to adopt AI across the SDLC rather than in one stage. And we've been using AI throughout the SDLC for a while now. We've initially built tools to help with requirements gathering and testing and pipelines, and we've created various skills along the way and always focused on all of the stages. And the recent PwC report classified the extent of AI across various organizations in the Middle East. And there were many organizations that are already looking at AI across most of the stages. So they classified 38% of the surveyed organizations as pioneers. So that means leveraging AI across 6 or more of the stages. Now, the interesting thing is that pioneers, they were self-reported as pioneers, shipped twice as fast and also saw a huge reduction in defects as well. So being more disciplined and adopting AI throughout has huge advantages. Now, the first thing we want to do is align on the way we view things and the way we like to think about things. And having such structured thinking around AI gives us better grounding, and it helps with the why and helps us decide the processes and tools we might need. So what should we be focusing on? So if the agent is writing all of the code and doing all of the testing, what should we be doing? And in agentic engineering, our job is predominantly about setting intent and verifying that intent. Again, this isn't AI assisted and it's not vibe coding, so we need to be verifying intent as well. And you might think of intent as just the specifications, but what we mean here is a lot more than that. We're referring to most of the artifacts across the SDLC. So that definitely includes things like architecture and the code as well. Now, undoubtedly with AI, you can create software much faster. You can one-shot a whole application if you wanted, especially with ultra code and loop engineering now. But if speed is the only focus, you'll definitely end up with a total mess. So you obviously need to be looking at quality as well. Now, the argument here is not that you should be balancing speed and quality. That's quite obvious. Our argument here is that you can do much better and you should be doing much better. So you should be reinvesting some of those speed gains that you get into creating better quality software. And because of because of agentic engineering, because of the nature of agentic engineering, better quality software is usually necessary. Not just it's the result of proper agentic engineering, just because of the risks and the challenges that it brings. So you should be adding more test cases, you should be handling more edge cases, you should be doing more research into what the right patterns are before you actually start on the work. And you should be providing a better user experience, probably. So basically, we can afford to do a lot more just because we can reinvest some of those speed gains into creating better quality software. Now, the first instinct is to think that we have less code to write, so we have less to do. But in reality, since we're producing so much more code, we need to verify a lot more. And verification, as you all know, is really, really difficult. Now, this paper showed that a quarter of the time teams were spending checking and fixing AI output. So because of that, the job actually got much, much harder. Now, to cope with this, we need to simplify wherever we can, so just so that we can make it practical and realistic for humans to actually verify. So part of the way we simplify verification is to reduce what we need to verify. Obviously, volume is one of the main problems with verification. And it helps to think of mistakes in two tiers. So you have those that can be caught by deterministic checks and those that cannot. So the non-deterministic checks tend to be the ones related to decisions. And usually once you've made those decisions, you can move them and find a way so that you can automate them as well. But also thinking about things that way also influence your decisions. So we want to be able to automate as much as possible. So that might influence the decisions that you make. And this has always been the case, obviously. So the way we structure our code base, for example, is for it to be as testable as possible. But here we're extending that concept to most decisions that we make. So in the upper right quadrant over there, where we have the human review, you'd have something like we're changing the way we're issuing access tokens, for example. And something like that, you would want a human to look at and take the final decision. Whereas in the lower right quadrant, where we have automation by AI, you would have something like a sort order on a screen, which we're happy for AI to take that decision. Now, what is high impact versus what is low impact is obviously very project specific. And this is something that we usually look at and discuss at the beginning of the project. It goes hand in hand with threat modeling, but also we update throughout as we're updating and changing things in the software. And there's this popular concept right now, which is the Winchester Mystery House. And this is describing the architectural sprawl that AI causes. And the article that describes it, that we've linked here, describes this as somewhat of a good thing. And the reason it's a good thing is that we're building software the way we prefer it, the way the individual prefers it. And the Winchester Mystery House was built by this widow that had an infinite budget, and she built whatever she wanted, whenever she wanted, or whatever the need was at the time. And that's exactly what an individual building software with AI right now looks like. Now, the problem is that enterprise software obviously shouldn't be built to the individual's taste because they're not the end user and not the only one that are going to be maintaining it. There's also the problem that features are so cheap now to build that everyone just forgets the cost of maintaining it in the long term. And usually that's the most expensive part of software. So uniformity and structure is still very important. And this is great for a fun project, but not for professional software. And this is also very related to technical debt. Now, people have mostly stopped worrying about technical debt, and the argument is that AI eventually can fix it really quickly, so we can afford to add more to it and waste more. But there's a breaking point where you've racked up too much technical debt, and you go beyond the point of no return, and now you have to rewrite the whole thing. And also, even before that point, the more technical debt that there is, the harder AI finds it to navigate the code base. So it starts producing more issues, it costs more to build features, and so on. If you have like 5 different architectures for the same thing, AI doesn't have a good model to base the next feature on, and you're just compounding that issue. So just as before we had AI and we were using AI for all of this, some technical debt is maybe fine, but you should be spending it more deliberately rather than being careless about it. And also our argument here is that because you're using AI, you can have less technical debt. So you can fix it up front rather than let it accumulate. which is probably a much better strategy, and it's related to, again, reinvesting the speed gains that we talked about before. So more than the code, the job now is all about decisions. So deciding what's important, capturing the decisions, deciding what to check, and checking whether agents adhered to decisions that you made. So now we're going to look at the structure around the model, harness engineering, the part we control and we should be investing as much as possible in. And the investment in this harness is what moves you away from vibe coding and into agentic engineering. So people obsess over which model to use. And obviously the model is very important. If you use a small model versus using a large model, it will make a huge difference. We saw this recently and briefly with Fable, which should be coming back soon, frankly. But the harness is just as important, sometimes even more so. And this all started with this paper that showed that GPT-4 did so much better at Sweetbench when they added a better harness. And the harness is many things. So it's how we structure the work, it's the context we feed, it's the skills that we're building, and it's what gives the model the best chance at success. So it's definitely not enough to just give a developer like the best model that you can. You need to invest time in building this harness to have good results. And your harness should be as model agnostic as possible. Again, models change all the time, so you shouldn't need to recreate the harness from scratch. And we're starting with context. And the first instinct people have is to add as much as they can to the context. But simply adding more doesn't give you better results. Most often it's the opposite, actually. So every extra token that you add costs more money. So tokens are doing round trips, everything you add, you're adding. It adds latency, so it slows things down. I'm sure you've had a thread where it was very long and it was taking ages for AI to come back. And just like humans, AI has very limited attention, and every token is competing for that. So you need to be very disciplined in curating the context. Now, a good rule of thumb is to keep the context to around 100,000 tokens. So when you're working with an agent, ideally you have this in front of you so that you can see how many tokens you're using. If you go above the 50% threshold of the context window that model allows, the model just gets dumber very quickly from there. So it's important that you monitor how many tokens you have in context. Now, another problem with how we instruct AI is that AI will tend to focus on the most salient point. So aspects that aren't in focus just get ignored. And in this example here, we tried this with Sonnet. So we asked Sonnet to pull a URL parameter and add it to HTML, but in our prompt, we focused on that Sonnet should keep the code as short and lightweight as possible. And it did. It gave us a single line of code. But the problem is that it ignored cross-site scripting and added a vulnerability here. So then we simply removed the bold part from the prompt. So the goal stopped being the code being short. And here it correctly identified that there could be a possible cross-site scripting vulnerability and added the right code. So the wording and the focus in your wording will have a huge impact on the result as well. And part of the context are these agent files. And earlier this year, there was a study that found that when you introduce these agent files to a code base, AI actually does worse. And these files also increase token usage by up to 20%. So your Claude MD file might actually be hurting rather than helping. And the reason, again, is that we tend to add as much as possible to the context. And these files are read every time, so they become expensive, not just in cost, but also in attention, like we talked about before. Now, it doesn't mean we shouldn't have these files. These files can be very useful. And the way you can think about this is that any instruction that you add to these files should pass this simple test. And the first question in this test is, can an agent infer this instruction from the code? Because if it can, then you probably don't need to add an instruction in the first place. But then the second question is, can it do it cheaply, or would it be too expensive to infer it every time? And if so, maybe you should add it as an instruction. Also, these files should be reviewed quite regularly. They should be part of the review process because these files are maintained by both humans but also agents, so they will bloat very quickly. And you should probably add some automated tests so that these files don't go above a certain maximum number of lines or file size. So the recommendation is shorter, sharper, and localized files. So you should have multiple of these files as well. You should have these files living as close as possible to where an agent would need them. And that takes advantage of dynamic context so that you're not bloating the context at the start, but only when they are needed. And if you look at what agents produce, there are these handful of failures that keep coming back. We've talked quite a bit about these in the past, and Andrei Karpathy lists these failure modes. So silent assumptions, over engineering, stray edits, and weak success criteria. Now, a couple of examples from our experience. So I was working on this very small Angular application, and I had a problem with binding. So I had a select, and the options weren't coming up. And I asked an agent to help with this issue. And what it did was it introduced Zone.js. So it took a framework library decision just to fix a very small bug. So this is a case of over-engineering, obviously. And we use .NET and then the framework a lot. And every time we need to add a migration, AI will try to write it manually. In fact, this is something that we add to our instruction files because it's something that AI cannot infer from the code. It doesn't know whether the class, a migration class, was added manually or through commands. So it will just try to edit manually. And the common thread here is that AI will fill the gaps unless we are very explicit about our intent and we're also verifying it. So in the case of the Zone.js library, it would have solved the problem. But I wouldn't have noticed unless I looked that it added the whole library rather than just fix the small problem that I had. And we've been talking about instructions, but the thing to keep in mind here is that instructions are just a direction, they're not a boundary. So it does help make it more likely for AI to do the right thing, but it doesn't mean it will. And that's why we need to verify. So let's talk briefly about verification as well. And the first thing we're looking at are AI plans. Now, these plans have a bad name. A lot of people don't use them or don't like them, but I really like these plans. And I like them for several reasons, but a big one is verifying intent. So you give AI your spec, what you want to build, and it comes back with this plan, which is a description of what it understood, what it will do, and it also tells you how it intends to verify as well, or how you should verify. And that's a very high leverage place to check in plain English whether what it understood and what it will do aligns or matches what you actually wanted. So that is before any code is written, it's cheaper and it's much quicker to correct at this stage. So obviously, getting direction wrong is the most expensive thing to get wrong. So the sooner you catch it, the better. Now we also persist these plans and we persist them for two main reasons. So one, it helps with traceability, but it also provides additional context down the line. And we're going to talk about that again when it comes to collaboration. So a few best practices when it comes to verification. So you should automate wherever you can. You should make sure that the verifier, if you have automated verifiers, they should be separate to the generators or the builders, at least have completely separate context. You should run as many deterministic checks as possible. Having a strong pipeline is very important with the usual things like linting, code analysis, SAS tools, license checks, very important with AI. And you should be protecting scarce human attention as much as possible. Now, an important thing to mention here is that if verification is part of the process, there's a risk that the builder will simply build to pass the verification, especially if you have an automated loop where it fixes automatically. And the problem is that verification becomes the target, and so it stops being a good measure, which is Goodhart's law. Now, with deterministic checks, part of the solution is to add mutation tests, and mutation tests make sure that tests will fail if the code changes in any meaningful way. And that is checking the quality of your tests. But that obviously leaves a gap when it comes to the non-deterministic stuff. And that's where you need human judgment and also where Nissi as a tool comes in and helps as well. Okay, so I'm going to hand over to Ethan so that he can walk us through the workflow in a bit more detail and also show us Nissi.
So, as the R&D team, we're always trying to improve our own SDLC first, and we wanted to share a bit the journey of how we applied these points that we mentioned to our own internal workflows. So we started by having the goal of optimizing these things, such as setting the intent properly, verifying it effectively, making sure that we account for Karpathy's failure modes and be careful of when AI fills the gaps between things, and also to respect the importance of persisting the decisions that are taken in conversations. So in order to do this, we started by looking all the way back to the artifact before we were all using AI, and essentially we boiled it down to just the developer with their intent sitting with their code as the main artifact, right? So the developer have their own experience, they read the user story, they know the project, and they have the ability to just drive that directly into the code. They can change the code, they can verify the code, they can iterate on top of it, essentially until they're happy with it, right? And then we compared this to the agentic instruction loop with AI, and we started seeing that there's a lot more going on, right? So now the developer, instead of changing the code directly, they need to somehow drive that context into a prompt that they give to the agent. And as we discussed, you cannot include everything that you know because you would dilute the attention. They also need to review their plan very thoroughly and make sure that it aligns with the direction they want. They need to supervise the agent as it's working to make sure that it's not going further than they intended. They also need to review the generated code that there is, and essentially the developer ended up being much farther away from the generated code, right? And of course, this is overwhelming, and by time, every feature that you add has to go through this loop over and over, which is also lossy because you might not put as much effort into the prompt, you might not review the entire plan, you stop supervising the agent to do something else, you might also not review the entire code, right? And inevitably these drift apart, and this is something we previously called vibe code drift. So vibe code drift is the process, and it explains the gap where that widens between the developer and the actual generated code at the end and what the agent does, resulting in dark code and dark features where the developer does not understand how these work internally. And this exact reason is why we started Nissi. So Nissi exists initially because we set out to measure the vibe code drift, by having a local tool which checks the way you're working. And this quickly evolved into an assistant that helps you stay more the owner of your code. So Nissi does this by attaching to the different parts of the agentic instruction loop, and it helps by helping come up with better prompts and be more selective with what you put in. It reduces the verification load of reviewing the entire plan, of completely supervising the agent, and essentially closes the loop between what the code generated is and your initial prompt. So Nissi is an R&D project we're working on. We're building it in the open. It's beta, but we've been using it internally and with clients, and we found it useful. So we wanted to share it with you and give it something to discuss and something we can perhaps adapt to more use cases. So Nissi is a desktop application that you install on your machine. And right now it works with the major coding harnesses, the Codex, Claude, and GitHub Copilot, and we're adding more as we go along. And it's able to work by hooking into two primary interaction points where it attaches before you send the message to your agent. So as soon as you enter the prompt, it checks it and aligns with best practices and makes sure you're not setting the agent up for failure. And then at the very end, when the agent delivers based on your prompt, it checks again and checks the entire interaction. So it measures the difference between what you asked and what the agent actually did in between. And then we realized that if we can do this for a single interaction, we were able to also do it over an entire conversation and sometimes even multiple conversations. So Nissi also gives some long-term patterns and insights into repetitive mistakes that you sometimes do and things that can be caught deterministically, and essentially helps you stay more in tune with the best practices. Of course, as developers ourselves, we're very protective of our data. So we sort of built Nissi to be local first, and your messages are stored on your machine like they already are by the harnesses. It has a local classifier for sensitive data, and the remote AI analysis that there is, it just sends the context that there is. It replies with your with any suggestion it has, and nothing is retained, and it sort of stops there. We also don't retain anything that Nissi actually produces because it's often personal and it's specific to projects. So we don't retain anything like that either. We also wanted to share a bit with you, how the experience using Nissi might look like. So we're going to try our luck with a bit of a live demo here.
Let me stop sharing my screen so you can share.
All right. So here I have a fresh instance of Claude. This is on a simple web project that I have locally. There's a backend, there's a front end. I mean, it's quite a normal project. And essentially, this is Nissi's main form here. It sits beside you as you code. It goes away when Claude is not being used, so it doesn't get in the way. And essentially, it's there to sort of support and give you messages as it's needed. So I'm going to try to run a use case here where I think it's something that we're all doing shamefully enough in 2026, where we dump an error log into Claude and we ask Claude for help, right? So here I send the message, and as we can see, Nissi caught something here, and it says that the message might contain sensitive data and it detected an IP address here. And if we look carefully enough, yeah, true enough, here there's a client IP address which we were about to send to Claude, and we can go ahead and choose to either send it or not, but in this case, we're going to cancel the send. And by doing that, Nissi intercepted the interaction from ever going to Anthropic or being shared externally. So this kicked in before Claude was able to read it. And this classification occurred by a local classifier that Nissi has, so it wasn't processed anywhere externally outside of my computer. There's also another example which we wanted to try, and this is the example that Aman used earlier, which is the JavaScript snippet that creates a welcome back banner that shows the user's name inside of the HTML, right? And we can send it. Nissi starts processing this, and it likely passes the local classifier. So it also sends it for remote analysis. And as we can see here, Nissi caught it in its pre-check, and it's telling us that we might be setting up the agent for failure here, and this directly inserting things into the HTML can cause cross-site scripting and is not safe, and that the agent should use the text content here, right, rather than inner HTML. And if we review the output here, Claude was smart enough to actually use text content. And if we actually go ahead with it, so here we can let it finish, and it's doing its other check during the post. But in this case, so although the cross-site scripting issue was not there, Nissi is telling us that the agent actually created a full HTML page instead of a snippet. And if we look at the prompt here, we asked for a JavaScript snippet specifically, but Claude gave us an entire HTML page with some with things we didn't specifically ask for, and as you can imagine, this really spirals, and we can see this really often in code where you ask for something quite simple and Claude might over-engineer it, right? And if we open the actual detailed page, so here we have the main app for Nissi, and although the orb is where it gives you the interactions, here you can get a bit more detail. And if we look at the messages tab here, we can see all our interactions that we had with Claude or our agent before. And for example, here we had an instance where I had a reporting page. It was just a table that I had, and I wanted to add a CSV export button. So I was quite generic perhaps, and just instructed it to Claude. Simple enough. But as we can see, after Claude's work, it created an entire job queue in order to create the CSV. And of course, that's not something I asked for. That was out of scope in this case, and it's something that Nissi flagged. Here it's saying that the agent went well beyond the ask. I just wanted an export, but it created an entire job queue, and it went much bigger than that. So it was something that I could redirect, and I could just ask that I just wanted a simple thing. But if this wasn't caught, I would like to have opened the page, clicked the export, seen that it worked, and I might have called it a day, right? There's also the aspect we mentioned where it tries to help you in the long term as well. So Nissi has the ability to generate long-term reports. And here, for example, we have a report which I generated over the last 3 days. And essentially, this gives a snapshot or a summary of how I'm using AI. So here, if you see the title, I worked on 3 small features during those days, and we can get some insight into the way that I use and interact AI. So here, it's saying that when I clarify requirements or boundaries, I tend to ask focused questions to agree with the agent. There is also the aspect where I wire the back end to the front end very thoroughly and focus on enforcing a proper contract here. And that comes from me being, primarily a full stack. So I've been bitten a lot by this in the past. And it's just some ideas about how you tend to work, right? There's also the aspect of the best practice rubric. So as you might have seen, the major AI labs, say OpenAI, Anthropic, and the like, they all have lists of guidelines that you should follow in order to prompt the agents effectively. And we were finding it a bit difficult to catch up with these and remember to use them. So here, these are aggregated here, and you can get personalized feedback on whether you're following them well or not. So for example, here, if we follow the verification defined, so a good practice is that you should tell Claude or the agent what you want to be verified beforehand, right? So if you want some specific verification to be run, you should specify that so Claude or the agent can essentially verify it themselves. But here, Nissi is telling me that I frequently verify the commands and the tests myself, but I don't usually state it beforehand, right? So it tends to be something last minute and that I tend to run at the end. At the very bottom here, we also have some practical tips. So instead of only nitpicking that you're not doing this well enough, it gives you something that you could try next time, right? So here we have, before you start the next change, write down 2 observable acceptance checks. And essentially, this would help the agent, know what it needs to verify beforehand. If we also look at the sessions tab here, as we mentioned, it's really important to surface the important decisions that went on in a conversation. So here I have an example where this is just a normal back and forth where I wanted to add a criteria type. I had a union in my code and I just wanted to add a type, and it's a normal back and forth, right? I asked Claude what I want to add this here, and that I want to add a union, make sure it shows up in the UI. And simple enough, Claude actually did this, delivered it back, and that was it, right? But this is not always the case. So for example, here, when I asked the agent to clean up the reporting module, of course, in mind, I had some old code that needed to be removed since it was no longer being used, but I just asked it to clean up, right? And in this case, it was caught that I gave no guidance when it came to it, but in this case, Claude handled it very well. it asked me, those questions about what I'm referring to. I confirmed it, and then it went on and did it, and it was in scope, right? Here we also have the example I showed earlier about the reports page where the agent built out a whole job queue, which I didn't actually intend. And it was caught here that I asked the question and the agent delivered something that exceeded the bounds of what I specified, right? And this is, a pure example of drift. It's something that I wouldn't have caught. And in this case, I was able to pivot. I asked it to actually create a button, as we saw, and it went well at the end. There's also some more major instances where, for example, here I had an issue with Entra and there was a loop, and I asked Claude to try and fix it. And after a couple of tries and it failed, it decided to remove the MSAL standard library and it tried to hand roll the authentication. I didn't know about this, of course, and here it's clear that it was going to cause destructive action and something that's security sensitive, and it's something to be careful of, right? But yeah, that's it. That's it for the demo. Of course, we're always improving this. We're excited to catch more cases, make it more accurate, and adapt it to many other use cases. And yeah, we're excited to build this out with you. Thank you.
Awesome. Thank you very much, Ethan. Right. Let me share my screen quickly. Share. So most of what we talked about so far was about the developer working with their agent. But when the developer is working in silo with their agent, the team has a problem. So decisions used to happen in a group between people, but now a lot of the decisions are made between the developer and their agent in chat. So we need to be very deliberate about building a shared understanding. Also, because of AI, the way we communicate changed, and not just in software. Like in every organization, everyone is sharing HTML files, for example, now to communicate their thoughts a lot better. A designer isn't handing over static designs or very rough prototypes to engineering now. They're capturing exactly what they want and building a working prototype. In the design phase, we've been using AI for a while, and tools have gotten a lot better. The handoff is usually the most painful part, especially going from engineering and back to design. And Anthropic, just as I know that Anthropic recently improved this with Claude Design and Claude Code. So now there are commands to go back and forth, and it really helps when you're building on top of existing components. And there are fewer of the usual arguments, like we cannot build this design because we don't have a component to base it on, or how should this behave on a different screen, for example. It's not just design, obviously, it's also product owners and business analysts can now create working prototypes to communicate with end users. And if we do this properly, it can tighten the feedback loop and we can move much faster. And in fact, many companies are now building infrastructure so that they can make throwaway prototypes. They can build throwaway prototypes directly on the code base. There's certainly a disadvantage when it comes to expectations here, because people see a piece of software and they think it's ready to ship. But everyone is exposed to vibe coding anyway. Like I said, everyone is creating HTML files, for example. So the default is that the expectations are skewed. And I think this is an opportunity for us to be more deliberate about it and align on what is shippable and what isn't. Now, in the agentic world, the spec and what we persist becomes a lot more important. So the starting point is usually that a developer starts working with their agent and they push code, and that's all that they persist. So the code and the initial specs are the only context that exists. Now, developers aren't getting stuck with trivial issues anymore like they used to in the past. So they used to discuss these trivial issues with their colleagues, and that helped have a shared understanding of what's going on. So we need to build a system that helps achieve that shared understanding across the team. And not just for other team members, even the developer building the features themselves are not as close to the code as they were before. They're not writing every single line of code. So their mental model is not as deep either. So recalling things also becomes harder. Now, the ultimate goal is for anyone on the team to be able to ask their agent why any decisions were made and how things work. And the agent should be able to answer that. And these are some of the elements that we persist to help with that. Now, the first one is obviously the spec. We've always stored that, even from before AI, but now it's a lot more detailed, so it helps a lot more. The second one, like I mentioned, are those AI plans, and that's a great place for agents to look and understand at what happened. Then the problem is that these plans go stale very quickly. So we want to be supplementing them with the micro decisions that the developer and the agent are taking as the build is happening. And that's exactly where Nissi helps. Now, having all of this persisted is very powerful because you can also run analysis on all of this. And with AI, AI can also help you improve the harness as well that we talked about previously. And the way we generally structure this is to have a roadmap, then we would have phases, and then we would have specs. So this is roughly what we had before as well. The specs would be things like designs, like ADRs, an intent manifest now or open spec. And usually these are stored in a project management tool like Jira or Azure DevOps. And now these first three items is where there is a need for a lot of human judgment. So AI obviously helps, but most of these decisions should be made by humans. And each spec has multiple AI plans, like I described before, and those we typically store as markdown files within the code. We also store agent tasks. So these task files just help if an agent crashes, for example, they can go back to where they were, or also it helps with multiple agents not stepping on each other's toes. And we have Nissi running with the developer at these two stages, obviously making sure that there is the right judgment there by the developer. Then at pipeline stage, and especially at PR stage, we have multiple agents running, and it helps to run these at PR stage because of auditing and traceability. It's a tool we've had before. So these agents can just add comments and it helps with traceability. Now, these agents can be very noisy. So if you get a QA agent and ask it to find an issue, it will find an issue. And that will annoy the developers. So having context and context that is improving really helps so that you don't surface the same false positives over and over again. And typically in our workflow, those comments go back to the author developer to fix before they then eventually move on to a human reviewer. Now, the great thing is that that human reviewer now has an agent that they can ask about any piece of code and why things exist and why certain decisions were made. So it's a lot more powerful than what we had before. And again, this is part of having better software now. And when it comes to Nissi, we only talked about the developer side of Nissi, but we've also been working on the organization side. So, like Ethan mentioned, Nissi started with us trying to measure vibe code drift, but we saw it evolve into more of a safety layer. So, we're making sure that there's a human in the loop when there should be. It helps with the maturity of the organization in SDLC because of the best practices and the rubrics, and we're helping the developer on a personal basis. And it also bridges the gap when it comes to regulations like EUA Act, for example, because it adds the necessary accountability as well. Now, something we're excited about when it comes to Nissi is that we're seeing that some of our clients that were hesitant in introducing agents in their SDLC were more confident because of Nissi and doing so. So that's quite exciting. All right, so in conclusion, the two most important points are that human judgment is very necessary, and it's much more difficult now because of all the noise. So we need to protect it by simplifying as much as we can. And the other thing is that we should be creating better software. So aiming for fewer defects, stronger tests, and more traceable decisions throughout. Now, none of this is a one size fits all. So an individual lives a very different reality from a new regulated entity that can't have servers in the US, for example, or a regulator that needs to have a model running on premise. So where you sit on this spectrum changes what a harness looks like for you or what agentic engineering actually means for you. So As a professional, you should be using AI as much as you can, but never beyond the point where you can take accountability for it. That's everything from our end. Hope you found the content useful and that you liked Nissi. If you want to try Nissi yourself, you'll be receiving an email with a download link so you can be the first to try it. And please do let us know how it goes. We're only just promoting it now to beta version, and we want to know what you think and how we can make it better. Let's see how we are on time. Okay, so maybe we can take a couple of questions. So the first question is Nissi looking at the code output then? Is it like a code review? Ethan, want to take that one?
Sure. So no, I think it's a bit more than that. So essentially, instead of only looking at the output, that the code was delivered at the very end, it looks at the entire chain of thought from the point that you ask the agent, with your prompt, all the way until it delivered it, right? So first of all, it can catch things as you're working with it. And of course, as we said, direction is expensive to get wrong. So the sooner you get it, the better. And it tries to, ground you throughout the entire loop. And you can just improve by being more the owner of your code rather than just at the end and fix the issues retroactively.
All right, another question that we have here is, does ultra code change any of what you're talking about today? All right, so I don't think it does. So we talked quite a bit about ultra code as well. We use ultra code as well. And I think all of the principles that we talked about today still apply. And I think the grounding is in accountability. So we need to have humans judging and taking the decisions at the end of the day. So if anything, ultra code actually makes it harder because it adds a lot of noise. It does help in certain cases, and we actually use ultracode. So the way we use ultracode is the exact same way that we described here. So we are very deliberate about our intent, and we still are very careful with our specifications, and we still verify. But sometimes ultracode is better at the tasks, and also with the auditing agents, like the auditing agents that we mentioned, ultracode is especially good there as well. Okay. So we have another question. Is Nissi also made of AI? Ethan, want to chip
Yes.
in there?
So yes, Nissi is also made of AI. There's a few, parts at play. There's a local classifier which stays on your machine, and it's a bit closer to the deterministic side. And there's also the remote analysis, which yes does use AI, but of course it's you're giving it a different context. Its entire purpose and its entire prompt is to verify things and make sure that you're staying in tune and catch discrepancies between them, right? So it's AI, yes, but of course it depends on the hat that the agent wears and that the AI is wearing.
All right, there's another question related to, I think it's very related. It's asking whether there's a local. I think you answered that. So those were all the questions we had. Uh, Again, for joining. Do get in touch if you want to discuss any of the topics we talked about. And definitely do give Nissi a try and let us know how it goes. So thank you very much.
Thanks, guys.